So far we've talked about hypotheses like the null hypothesis or the alternative hypothesis. We've also talked about p-values and making the right conclusion, like should we reject the null, do we fail to reject the null? And in these notes we're going to talk about the types of errors we could make. And there's two types in particular. There's a type 1 error or a type 2 error. So in doing that, we're going to relate it to a jury trial. What are the two errors that a jury could make as far as convicting someone? Well, the first, and perhaps the most unfortunate, they could convict an innocent person, right? Which basically means they're going to send someone to jail, let's say, who is innocent. So that would definitely be an error and something we wouldn't like to see happen. The other error they could make, let's go the other way. What if they don't convict that person? Basically, they're letting an innocent person, a guilty person, go free. So there's two sides to that coin. They could let a guilty person go free. That would also be an error. Or the first one, they could send an innocent person to jail. So these two errors, in the context of a jury here, relate directly to the two types of errors we could make when we're making stats conclusions. So let's start with, let's make a little table here. You can make it pretty much square. It's got 4 corners. And we're going to sort out these decisions. So for the columns of this guy, we're going to look at the truth about the population. And by the truth, I mean, well, there's only two things that could happen. If you have two hypotheses, one's right and one's wrong. So either the null is true, H sub 0 here, or the alternative is true. In most cases, we'll probably never know which one's actually true, but we're going to make a conclusion. And for the rows here, we're going to give both possible conclusions that we can make. So this is going to be our conclusion based on whatever sample data we have as statisticians. So conclusion we make based on sample data. And if you remember from the previous notes, there's only two conclusions we can make. We can either reject the null hypothesis, which favors the alternative hypothesis, or we can fail to reject the null hypothesis. Those are the only two conclusions we can make. And notice they're both in terms of the null hypothesis. It's almost like guilty, not guilty. All right, so again, the columns here, that is the truth about the reality. Whatever the population, whether the null's true or the alternative's true, right? And then here's the decisions we're faced with. We can make either one of these decisions. So let's go to the first cell here, where the null is actually true, and we decided to reject it. Well, right away that sounds wrong, right? That is an error. In fact, that's a type 1 error. If the null hypothesis was actually true, and we rejected it because we were in favor of the alternative, well, that's a mistake. In fact, you can think about that as sending an innocent person to jail. So we rejected a hypothesis that we shouldn't have because it was actually true. That would align with the scenario, the jury scenario, where you convict an innocent person. All right, so let's move across the table to the right here in this cell. It looks like the alternative is true here, and we chose to reject the null. Well, that would actually be the right decision. If the alternative is true, not the null, we should reject the null hypothesis. So that one gets a smiley face. This would be the correct decision. So a smiley face there, and let's go bottom left corner here. Null hypothesis is true, and we failed to reject it. That's actually a good thing. Right? The null was true. It would be wrong to reject it then, right? That was an error. So if we fail to reject it, that's actually the right decision. So that one gets a smiley face also. And then bottom right corner, the alternative is actually the true one. But for some reason, we failed to reject the null. Well, that would actually be the wrong conclusion on our part then. If the alternative is true, we should be rejecting the null hypothesis. So if we fail to reject it, that's an error, namely a type 2 error, which corresponds to failing to convict a guilty person or letting a guilty person go free. Right? That would be a type 2 error as far as the jury goes. So as far as the errors go, there's two of them. We call one type 1, one a type 2. A type 1 error, that happens when we reject the null hypothesis, when in reality the null hypothesis is actually true, right? So that's the wrong decision. And as far as the jury goes, that's the equivalent of sending an innocent person to jail. A type 2 error, on the other hand, that's like letting a guilty person go free. So in this case, we fail to convict or fail to reject the null hypothesis when the alternative is actually the true claim. So which one is actually worse or more offensive? That honestly just depends on the situation. In society, I mean, especially if we're talking about the jury trial, our society would say a type 1 error is worse, right? Sending an innocent person to jail is more offensive than letting an innocent person go free. But it's not all the time jury trials, so it really just depends on the situation. Okay, one really easy way to remember which one is which. For a type 2 error, it's fail to reject. So at the top of the page here, if you have to remember this for a test, right? Or the AP exam, let's say, which one's type 1, which one's type 2? Well, remember type 2, we fail to reject. So if you put the Roman numeral 2 in there, that's sort of a hint. Type 2, you fail to reject the null when you should have. So definitely make that note. If you're out of room, go ahead and put it at the top of the page. All right, and let's scroll down here. It says, describe a type 1 and type 2 error in the context of the CEO example. Which error could the researchers have made? Explain. So if you remember from the CEOs, the null hypothesis would have been that the birthdays are all fair, right? So June and July, the probability should just be 2 out of 12 months. That was the null. The alternative, which the sample data sort of suggested, well, it actually very much suggested, was that true proportion was actually less than 2 out of 12 for those June-July birthdays, as far as the CEOs are concerned. So what would a type 1 error be in this case? The one where it's like sending an innocent person to jail. So a type 1 would mean we reject the null, but we have to say it in context. So we would reject the claim of fair birthdays, right? That the P is 2 out of 12 for the population of CEOs. When in reality, we shouldn't have done that because the birthdays were fair. So that would be an error. Right? So when in reality, the birthdays are actually uniformly distributed. Meaning, same proportion of CEOs born each month of the year. So that's one way we could make a mistake, the type 1 error. You reject that fair birthdays claim for all the CEOs, when in reality, CEOs' birthdays are, for the most part, uniformly distributed. Okay, how about for a type 2 error? And I'll use purple for this one. Remember, for type 2, it's fail to reject. So we fail to reject that fair birthdays claim, right? So a type 2 error in this case would be failing to reject the fair B-days claim when we actually should have, because, like the sample data suggested, apparently June, July birthdays would be to disadvantage, right? So when in reality, June, July B days have a CEO disadvantage. So type 2 is fail to reject. That's the way we could have made that error. We talked about the type 1 error. And then the question asked, which error could the researchers have made? So if you remember from the last notes, the p-value was actually really small. So since the p-value was so small, 0.008, they most certainly rejected the null hypothesis, right? That is definitely statistically significant and way below any reasonable alpha level, right? So since the p-value was so small, researchers rejected the null in favor of the alternative. Basically saying they support the claim that June, July birthdays are at a disadvantage as far as CEOs go. Are they right? I don't know. It's still just their educated guess from the 300 or so CEOs that they interviewed. So, having rejected the null, which one of these two errors could they possibly have made? Well, if you'll notice, only one of them chooses to reject the null, right? Type 2 fails to reject the null. So, they could have made a type 2. Rejecting the null means you could have technically made a type 1 error. So, since they rejected the null, they could have possibly made a type 1 error. If they had failed to reject the null, well, then they would have been at risk of making a type 2 error and not a type 1 error. But in this case, since they rejected it, their only risk would be having made a type 1 error. Okay, the last part of these notes here, it starts off with what is the probability of actually making a type 1 error? Okay, and something we need to keep in mind is that when we're doing these conclusions, to reject the null, something special has to happen, right? Or to be statistically significant. Our p-value, because it depends on our p-value, it must be small, right? It must be below the alpha significance level, whatever that is, whether it's 0.05 or 0.01. So our p-value has to be rare enough below the alpha significance level for us to reject the null hypothesis. And if we reject the null, we're actually at risk of making a type 1 error. So the probability of a type 1 error, and let's think about what goes into making a type 1 error, right? That's the probability that we reject the null hypothesis given that the null is true, right? So it's a conditional probability. You made the choice to reject the null hypothesis when the null is actually true. So to reject the null hypothesis, our p-value has to actually be under that alpha significance level. And the math behind this is actually really simple. Alpha is the probability of a type 1 error. So if you tell me alpha is 0.05, I would tell you the probability that you make a type 1 error is 0.05. If you told me it was 0.1, I'd tell you it's 0.1. So that's actually really convenient. Type 2 is not so obvious. But we're only talking about type 1 for now. So what can we do then to reduce the probability of a type 1 error? So to reduce the probability of us making a type 1 error, well, if you remember from the last notes, alpha is something that we as statisticians can set. It depends on how picky we are, whether we want to use 0.05 or 0.01 or 0.1. So if you want to directly change the probability of a type 1 error, you could just make the alpha smaller, right? Since alpha, whatever our significance level is the probability of a type 1 error. So that's one dead giveaway, and that's a way that we can reduce the probability of a type 1 error right away. Are there any drawbacks? Yeah, there is a drawback or sort of a trade-off. Something that you might guess. If you reduce the probability of a type 1 error, something else goes up. And actually, that's the probability of a type 2 error. because if you make alpha really small, like 0.005, it becomes almost impossible for us to reject any null hypothesis. So we would just fail to reject almost everything. And if you're failing to reject, that's when you're at risk for a type 2. So if you increase alpha, yeah, you increase the probability of a type 1 error, but you would also increase the probability of a type 2 error. So there's a trade-off there. All right, so that's everything you need to know about type 1 and type 2 errors for now. Don't forget, a type 2 error means fail to reject. And probably the most important skill is being able to describe what those errors would represent in context, like this example. All right, that's all for these notes. I'll see you in class.